Good morning, dear children. Happy New Year. How was your vacation? I hope you all enjoyed your holidays. Do you remember which chapter we were learning? Yes, we were learning the chapter Separation of Substances. Can you recall which method is used to separate an insoluble solid from a liquid? Yes, we may use sedimentation and decantation to separate an insoluble solid from a liquid. Suppose we take a mixture of sand and water. We can see that insoluble soil settles down after some time, and that process is called as sedimentation, and the supernatant liquid can be separated from the solid by simply tilting the vessel, and that process is termed as decantation. So that is the simplest method to separate an insoluble solid from a liquid. Suppose we are taking some clay. Instead of sand, we are taking some clay and mixing it with water. So the mixture we have is that of clay and water. Here also we can do sedimentation, but it will be taking a long time to settle down as clay particles are very small when comparing to sand. So can we do something so that it settles down easily? Or even when we do decantation of clay and water, we may be finding that there is some particles of soil in the water. So it remains colored or translucent. So in order to avoid that situation or to make all the particles settle, is there any method? Yes, we are going to learn that method, and it is termed as loading. So loading is the method used to settle down the small particles of clay in the water. For this, we need to add a substance or a chemical substance called alum. Alum is added to this liquid mixture and mixed well so that the small particles come closer to each other and become large in size and settles down easily. And this process is termed as loading. Let's do an activity.
For this activity, we take 4 glass tumblers, water, sand, clay, a glass or wooden rod, some amount of alum. Now let's start the experiment. Half fill first, second and third glass tumblers and label them as A, B and C. Now add some sand into first beaker, then clay into B as well as C. Now stir all the glasses well. Then wait for some time. After some time, we observe that the sand settled down in beaker A. On the other hand, clay in beaker B and C take a long time to settle down. Now take some water in the fourth glass tumbler and add some alum into it. Stir it well to prepare the alum solution. Now stir all the glass tumblers well. Now add some alum solution into the third glass tumbler and stir it well. Leave the tumblers undisturbed for some time. After some time, we observe that the sand in first beaker settled down easily. And after some time, we can see the clay in third tumbler in which alum was added also got settled down. On the other hand, in beaker B, clay did not settle down. This proves that alum helps in fast sedimentation.
So, here in this activity, you observe that sand settles easily so that we can do sedimentation and decantation easily. In the second beaker, there was clay in water. It takes a lot of time to settle down. It's very difficult to settle the clay particles. But in the third beaker, even though it was having clay, after adding the alum to it, what happens is the clay particles become large in size and settles down easily. And that process is termed as loading. So loading helps the sedimentation process to take place easily. That is, loading is the process in which small particles come closer to each other and becomes larger and settles down. Here, in this situation, we are using a chemical substance called alum. But is it alum that is used in all the situations? No, in different situations we use different substances for this loading to take place. We may also call this process as coagulation. For this, we use different substances. For example, you all know that after rain, the atmosphere seems to be clear. Why? Because in normal atmosphere, there is a lot of dust particles. Small, tiny dust particles. When it rains, the rainwater makes the dust particles come closer to each other and allows the dust particle to settle down. As a result, the atmosphere becomes clear. So that is also a loading process. Can you identify any more loading process? Is milk a mixture? Yes, you all know that milk contains milk solids as well as water. Can we separate these substances from each other? Normally, by sedimentation, decantation or even by filtration, we cannot do it. Even after using the filter paper having the smallest hole, we cannot separate the milk solids from milk. So how can we separate the milk solids from milk? Let's see.
Take some milk in a vessel. Start heating the vessel. When it becomes hot, add some lemon juice into it. Stir it well. Remove it from heat and allow it to stand for some time. After some time, we can see that the milk solids got separated from water.
Here you can see that we can separate milk solids from water. For doing this, we add some lemon juice to it. So what is the role of this lemon juice? Yes, lemon juice makes the milk solids come closer to each other and finally it settles down. So that we can do filtration to separate the milk solids from the liquid. So here also loading takes place and the substance added to separate milk solid is not alum, but instead it is lemon juice. Okay, I hope you are clear with the process of loading. Now there's a question for you.
Why do you sprinkle water before sweeping a dusty room?
Okay, dear children, so see you in the next session. Thank you.